Hi everyone, this is Mrs. Leong, and this is lesson 2.1, Relations and Functions. All right, so a relation is just a general relationship between two variables, and usually it's like a set of ordered pairs or an equation or a graph. And there's no really rules to it, so it's just very general. However, a function is a more specific relation in which each element of the domain is paired with exactly one element of the range. So if you look at this mapping right here, we see that every x value has exactly one y value. So that is considered a function. It's okay that they go to the same y value here, but notice there's only one output for each of those inputs. What would make it not a function is if, let's say, -6 went to 0 and it also went to 2. Then it would not be a function. Right? And another even more specific relationship is a one-to-one function where each element of the domain pairs to exactly one unique element of the range. So this one would not be one-to-one because this is not unique, right? They go to the same value instead of a unique one. This is considered a one-to-one function because each one is going to a different output. All right, so let me show you an example. This one, it says state the domain and range of the relation and does it represent a function? If it is a function, determine if it's one-to-one. All right, so the domain are all the inputs. So I'm just going to use D, and I'm going to list my values of the inputs, the X right there as my domain. The range, I'm going to go ahead and list out all the outputs, which are the Y. All right. Now, to determine if it's a function, I have to make sure that each x value has just one y value. So none of these numbers are repeating. So yes, this is a function. If, however, this was a 0 here, then this would cease to be a function because that means the input of 0 goes to two different y values. All right, but since that doesn't happen, I'm going to say yes, it's a function. And let me check if it's one-to-one. These numbers aren't repeated, so each one is a unique output. So it's one-to-one. All right, and then that's my answer for that example. Okay, let me show you a few more. This one, they write in ordered pairs, same directions. So the domain in this case are my inputs. And notice the 0.4 repeats, so I'm not going to write that one twice. I'm also going to write it from least to greatest. So 0.4, 0.5, 3.1. And then the range will be these values, again going from least to greatest. All right, now since the 0.4 I noticed repeated, right, that is not a function. That input goes to two different outputs. So this is not a function. All right. Number 2, I look at my domain and I go from least to greatest, giving me that. My range, going from least to greatest, gets me that. All right, I notice none of my input elements are repeated, so it is a function. However, because of these twos, those are not unique outputs. So it's function, but not one-to-one. Not one-to-one. All right. For quizzes or tests, please make sure you specify that it's not one-to-one as opposed to just leaving it blank. That way I can tell the difference between somebody forgetting to answer the question versus answering it correctly. All right, why don't you guys try number 3 and 4 so you can pause the video, and then once you're done, unpause it and the answers will pop up. All right, so here are the answers for 3 and 4. For number 3, that's the domain, the range, it's a function, and it's one-to-one. Answer for number 4, We have the domain, the range, it's a function, and it's not one-to-one. Okay, let's flip to the back. Here we go. Same examples, but now in a different form. They want you to graph it first, and based off of that graph, determine the domain and range, and determine if it's a function or whether or not it's one-to-one. And then we'll talk about this discrete or continuous in the directions too. All right, so for number one, this is going to be a parabola. If you didn't know that, that's okay. You can plug in numbers for x and y, and you can get a bunch of points to plot. All right, so we got 0, -1, 1, 0, 2, 3. Let's go to the other side as well. If I plug in -1, I also get 0. If I plug in -2, I also get 3. So you see this parabola forming, this U shape. Okay, and then let's go ahead and determine the domain and range. All right, for the domain, what I think is what values of x are on this graph? Now, since this goes all the way to the left, and this, the graph eventually will go all the way to the right, if I just make this obvious more like that, I get all real numbers. Every single x value will be on this graph. So all real numbers, and you can use that symbol right there. For the range, I'm looking at what y values are on the graph. So I'm kind of like scanning along the y-axis, and I'm like, I don't have graph, I don't have graph, I don't have graph, until I hit this -1 right there, all right, where y is -1. So I have graph everywhere from -1 and up, all right, -1 and up. So that was going to be my range. Y is greater than or equal to -1. All right. Checking to see if this is a function. I want to see if every x value has one y value. So as you can see, all these x values, I can connect to just one y values. There's no point in the graph where I get 2. And so this is a function. And that's where you get this thing called, let me go back to the front, the vertical line test. All right. So if you're given a graph of the relation, you can use the vertical line test to test if it's a function. And the vertical line test is basically where, when you cut the graph with vertical lines, does it only hit the graph once? And if the answer is yes, then it's a function. If the answer is no, then it is not a function. All right. This is not a one-to-one function, however, because if you see this value of -2 and 2, they share the same y value of 3. So because of that, this is not one-to-one. And you can almost think of it like a horizontal line test to test if it's one-to-one. So not 1-to-1. All right, I'll go back for the continuous and discrete later. Let's go ahead and try this next one. All right, so this one is a vertical line, x is equal to 3. Hits that at 3. So the domain for this one, if I'm going along the x-axis, the only time I hit graph is right at 3. All right, so the domain here is just x is equal to 3. The range, however, as I scan along my y-axis, I have every single y value possible on this graph. So this is going to be all real numbers. Vertical line test doesn't pass, okay? That definitely hits multiple points. So this is not a function. So I don't even need to worry about one-to-one. If it's not a function, it can't be a one-to-one function. So don't even test that. All right, and we'll go back for the discrete versus continuous later. All right, this one, they already have the graph for you, so let's just set the domain. In this case, I only have graphs at these specific points. So I only have a domain of 1, 2, 3, 4, 5, 6. All right, since those dots are not connected, those are the only x values that show up on this graph. And same with the range, I only have 3, 4, 5, 6. Because on the y's, I only have these values pop up on my graph. Vertical line test only hits one dot each vertical line. So this is a function. However, it's not unique. Yeah, so I see these two share the same output, same y value, so this is not 1 to 1. Okay. Now going back for discrete continuous, basically continuous means it's continuous. When you graph it, you don't have to pick up your pen or your pencil. So these two would be considered continuous. Continuous. And number 3 would be discrete, because you would have to pick up your pen in order to make that graph. So this one is discrete. All right. Cool. Going on to the second half of this lesson. This is talking about function notation. All right, function notation, something you end up using quite a lot in pre-calc and calculus, so good to know. And function notation is when you have two variables. One is the independent variable, which is x, and the other is the dependent variable, the y. All right. And then you have function notation that looks like this. You're given a function, f, that's defined, and usually you're asked to substitute something into it. So in this case, you're asked to substitute x is 3. So replace all your x's here in the equation with 3. So I like to use parentheses. I think it keeps me safe, especially when it comes to negative numbers. And there you go. Okay. Same thing here. For part B, I'm going to replace all my x's now with 5a. So I'm going to replace both of those x's with 5a, use parentheses. Make sure that square is on the outside of that parenthesis. Oops, that should be an a. And I'll get you 25a squared plus 15a. And that's as simplified as you can get. I know some of you guys might want to try to factor that, but it doesn't say factor, all right? And in order for it to be simplified, it should actually not be factored. Okay, why don't you guys try the rest? So you guys can go ahead and pause the video, and once you're ready to check your answers, go ahead and unpause it. All right, so here are the answers for the rest of the page. Only continue if you're ready to see these answers. Here we go. Number 5, it's negative 20. 6, negative 4b plus 4. And number 7 was negative 2x minus 2y plus 4. Okay, number 8 was 120. 9, negative 6. And 10, 343c cubed minus 7c. Again, make sure you do not factor that. All right, that's the end of this lesson.